Okay, hi everyone. Today we are going to be talking about graphing radicals. So there's a few things that we need to talk about before we actually start graphing things, and that is the domain and range and perfect squares. These things are going to help us understand our graph a little bit better, and perfect squares are going to help us pick the values that we want to substitute in for x that will benefit us the most. So starting off with domain and range, I like to use Dixroy. It just helps me remember what everything actually stands for. So when I talk about the D, it's the domain. So that's talking about all of the input values, the numbers that I will plug into my equation. And those values are my x values. Also, when I look at a graph, I am looking at all of the x's that are in my graph. The ROI stands for the range. So when I talk about a range, I'm talking about the output values. When I input a number, what I get out after I solve, that is part of my range. Those are called my outputs. And when I look at a graph, I am talking about all of the y values that are part of my graph. And that'll make sense a little bit more as we're working along. So I also want to remind you guys of perfect squares. Perfect squares are numbers that have a square root. Now, all numbers have a square root. It's just they're not always whole numbers. So we want to focus on these. It'll make solving things like this a lot simpler if I know that a whole number will come out. And since I get to decide what number x is, I want to decide numbers and I want to pick them based on my perfect squares. Another really important thing in this section is that we will not be using a plus or minus symbol. We will only be using the positives. And that's important when we start looking at the graph itself, because we'll see that there are numbers that are not part of our graph. This graph doesn't cover all numbers. It's only certain ones. So if you want to follow along with the textbook, this is section 5.3. So we're taking a step backwards. But it's the same ideas that we covered with evaluating when we were checking extraneous solutions. So it's familiar. We're just taking it into a little bit of a different direction. So let me start off with the first one. This one is going to be our parent function. We have done parent functions for parabolas and absolute values. Now this one is going to be for a radical. This is the square root of x. There's parent functions for the cubed root or the fifth root. But right now we're only going to focus on the square roots. What I'm going to do is I randomly pick some points. You see that I did 0, 1, 2, and then I skipped 3. That was intentional. And then I went on to 4. And I'll explain why I skipped it in just a second. But let's go ahead and get started. I picked that x is equal to -1. So in my equation, I am going to plug in that -1 in for my x's. So that's going to look like f of -1 is equal to the square root of -1. Now this looks really familiar. That's not one of my perfect squares. +1 is, but -1 is not. If you guys remember back in, I think it was chapter 2, we determined that the square root of -1 is actually I. And I stands for imaginary numbers. And if something is imaginary, that means it's not real. So we can't actually graph -1 because it's not part of our graph. It's not part of our equation. It makes a false statement, something that is not real. So what I'm going to do, I'm just going to go ahead and cross out that box because there's no part of my graph where x is -1. I'm going to switch colors as I'm working just because I don't have that much room. And the different colors will show you the different numbers that I actually plugged in. So here will be f of 0 and the square root of 0. So you'll notice that that is one of my perfect squares. The square root of 0 is 0, so I can go ahead and put that in my table. And I'm just going to go ahead and plot it. So there it is, 0, 0. I'm going to go back to green. I'm going to say f of 1 is the square root of 1. So I plugged in this value into this equation. Now I notice, again, I have a perfect square, and I know that the square root of 1 is equal to 1. So I'm just going to put that right here, and that point is there. Now I'm going to move on to 2. F of 2 is equal to the square root of 2. Now, the square root of 2 is not one of my perfect squares. I can simplify this and use a decimal, and it would be 1.414328, I think. But I don't want to deal with decimals. So I'm going to put it back in my table because there's a spot for it. But I'm not going to put it in my graph just because I know it would be an approximation. It's kind of like a closest guess. I'm just going to jump over to 4. The reason I didn't put the 3 is because I know that the 3 is not part of my perfect squares. So I would be left with just another kind of like a dud point, something I don't want to use. Now the square root of 4 is right here, which I know is 2. And I am going to graph that. So I'm going to go on my x, I'm going to go to 4. And then on my f of x, which is my y, I'm going to go up to 2. Like that. Now, I could keep going with this, but I like 3 points. I think it's enough. So I'm just going to graph like this. Now, this would be a good point to stop and rewind if you want to kind of take it one more time to make sure that you're good. The next thing I want to do here, though, is I want to talk about, again, my dictionary, my domain and range. So I know that my domain is talking about all of the x values, and my range is talking about all of my y values. Now, when I look at this to determine my domain and range, I want to focus on one point in particular in my graph, and I'm going to call it my vertex. It's going to be this point right here, the point where it kind of starts. Sometimes when you create your table, you'll have to make sure that that is that point. I know that this is my point because the number I plugged in after it, it didn't work. So that's going to be what I call my vertex. And I'm using that word very loosely. It's just the tip of my graph. And that vertex is, in this case, 0, 0. Now, every coordinate point has an x value and it has a y value. So what I'm going to do is I'm going to take the x value of that vertex and I'm going to put it with my domain. And I'm going to take the y value of that same vertex and I'm going to use it with my range. Because remember that my range has all of my y values and my domain has all of my x values. Now there's something really important that I need to determine here now. I need to know, are my x values going to be greater than or equal to 0? Or are they going to be less than or equal to 0? So I look at my graph and I'm only talking about my x values. So I'm looking left to right. So from this point, is my graph on the left or the right? Meaning, are the values of my graph, are they going to be greater than 0? Or are they going to be less than that 0? And you can see here that here's the 0 and the values to the right, meaning greater than, are the values that are part of my graph. So I am going to say that x is greater than or equal to 0. Another way of saying that would be all positive numbers, because it's true, any number that is bigger than 0 is positive. Now I look at my range. I'm looking at up or down now. So again, I look at this point and I'm asking myself, are the numbers going to be greater, meaning they're on top, or are they going to be less, meaning they're on bottom? And it doesn't necessarily have to be on the axis. It's just on top or on bottom. Greater than or less than. And we see that they're greater than. So y is going to be greater than or equal to 0. And again, another way of saying that is all positive y values. So looking at the next one, I am going to solve this one. Now we notice that this one is a little bit different. It has something else instead of that radical, and then we're adding something at the end. So instead of randomly picking some numbers to plug in for x, I want to be smart about this, and I want to manipulate that value so that I can do as little work as possible. I'm going to think back to my perfect squares. I know that my perfect squares are 0, 1, 4, 9, 16, and so on. So what I want to do is I want to make sure that whatever number I plug in for x is going to give me something inside of the radical that is one of these numbers. That means I want the inside of this radical to equal 0, 1, 4, 9, 16, 25, 36, so on and so forth, just depending on how far I want to go. So I am going to take this off to the side, and I am going to set it equal to 0, because that's my first perfect square. I'm going to set this in here equal to 0. I want to know, what do I plug in for x so that inside of the radical I get it equal to 0? And it just becomes a really simple equation. I add 4 to get rid of it, to get the x by itself, because that's what I want to solve for. And I get 4 is equal to x. That means that if I were to plug in 4 in place of the x in here, I would get 0, making it a perfect square. So that first point I am going to pick for x is going to be 4 because of this. Now I'm going to do it again, and I'm not going to show my steps as much now. I'm going to use 1, which is the next perfect square, so x minus 4. Move the 4 over, and I get 5 is equal to x. I know that would give me a perfect square inside, and again, I can try it. 5 minus 4 is 1, which is listed in my perfect squares. The next one I'm going to do is, I want it to equal 4, so this is where I'm getting my numbers from. I want it to equal 4, so I'm going to say, I'll just do it here. 4 is equal to x minus 4. Add 4 to both sides, so 8 is equal to x. And I'm just going to leave it at that. I like the idea of 3 points. It just seems enough to me. So now I want to substitute these values into my equation and find the output, the y value. So I am going to show my work down here, and just enough. I'm not going to go too deep into my work. So instead of the x, I'm going to replace it with that 4. So f of 4 is, instead of x, 4 minus 4 plus 2. So 4 minus 4 is 0 plus 2. Well, the square root of 0 is 0. 0 plus 2 is 2. I could do the same thing with the 5. F of 5 is 5 minus 4 plus 2, which is the square root of 1, plus 2, which is the square root of 1 is 1, plus 2 gives me 3. Or I can do it mentally, which is what I prefer. So 8. I'm going to say 8 minus 4 is 4. The square root of 4 is 2. So 2 plus 2 gives me 4. Okay, now I'm just going to go ahead and start graphing those points. Going to say 4, 2, so 1, 2, 3, 4, up 2, 5, 3, and then 8. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, and 4. And there it goes. Now again, we just need our domain, which is all of my x values, and my range, which is all of the y values that are on that line, on that graph. I'm going to take that vertex that I called, which is 4, 2. The x value of my vertex goes with my domain. The y value goes with my range. And again, I'm just going to determine whether it's greater than or less than. So here is my 4. I can see that all of the values are going to be greater than because they're to the right. And here is my 2. I see that they're all above, therefore it's that again. So let me zoom out so you can see the whole problem. And there's that. I'm going to do one more, and it does have an additional step in there. That might be a little tricky. This would be a good time to stop and try it on your own and see how you do. So again, I want the inside of this to be a perfect square. So I am going to take that and make it equal to 0. Make it equal to 1. Make it equal to 4. Make it equal to 9. And we'll see how many points I can get out of that. So move the 2 over. That would give me -2 divided by 2. So I'm going to use x is equal to -1. Move this over. I'll do the steps on this one. So move this over. That cancels this out, and I am left with -1 is equal to 2x. Well, that's going to give me a fraction, so I don't even want to deal with that one. I'm just going to move on to the next one. So subtract 2, subtract 2. I'm left with 2x, or 2 is equal to 2x, so x is equal to 1. That one's nice to work with. Again, move it over. That would give me a 7, so I don't want to deal with that one. And then the next one I'm going to do is I'm going to try 16 because I want at least 3 points. So 16 is equal to 2x plus 2. Move that over. That is 14 is equal to 2x. So I'm going to use 7. Now you see how this is all kind of cramped together and it looks confusing because it's the same color. That's why I decided to do alternating colors up here just so you can see the difference. But I didn't do it for this. My bad. All right, now I'm not going to show my work for this part. I'm going to do it mentally and just talk it out loud. So -1. 2 times -1 is -2. -2 plus 2 is 0. So this is just 0. The negative doesn't matter when it's a 0. So I get 4. Again, 2 times 1 is 2. 2 plus 2 is 4. And the square root of 4 is 2. So this part here equals 2. -2 plus 4 gives me 2. And now I'm going to try the 7. So 2 times 7 is 14, plus 2 is 16. The square root of 16 is 4. It's a negative. So -4 plus 4 is 0. Now that I have my 3 points, I'm just going to go ahead and graph them. -1 and 4. There. 1 and 2 puts me there. 7, 1, 2, 3, 4, 5, 6, and 7 puts me there. All right. Now my vertex is that point where it starts. So I'm going to make it slightly bigger right there. And that point is -1, 4. I'm going to do my domains and ranges now. Domain is my x value. My range is my y value. Now my range is going to be the y value, so I'm going to put 4 here. My domain is my x value, so I'm going to put -1. All I need to determine now is whether it'll be bigger or smaller. So looking at my x's, I'm looking left to right. From this point, are my x's going to be greater, meaning to the right, or are they to the left? I can see they're to the right, so this is going to be greater than or equal to. My range, I'm going to look up or down. So is it greater, meaning above, or is it less than, meaning it's below? And we can see that it's less than, so that means that y is less than or equal to 4. Now, as a whole, there's a few things that might look familiar. So here, you might think back to chapter 1 when we did transformations, and you see that when it's inside, you would do the opposite. So this is 4 to the right and 2 up. So starting from that original 0, 0 vertex, I went 4 to the right and 2 up, and that's exactly what I did. But if I try to do that with this one, it wouldn't really work. And that's because the 4 does work. You go 4 up, but then that 2, you didn't go 2 to the left. You only went 1. But also you have this negative transformation here, which tells us which direction it's going to open when we're talking about parabolas. And in this one, you went from being up here to flipping it upside down, and now it's down here. So some of the transformations are the same, but whenever you have this number in here in front of the x, that coefficient, it kind of throws everything else off. So just be careful of that. Be aware of it. Use it as you want. You can check the outside numbers and the negative in the front, but just be aware of this number in here and what it does to your equation. So that's about it. I would rewind and rewatch certain parts that you need as much as you need. And I will see you guys in class. Have a good day.